happy being here after the hard couple of years with the international pandemic. So I'm really glad to be back to India. And I'm happy to represent my company here, Glatt Group. Maybe you heard about it already. We are actually a hidden global champion, let's say in this way, and I would like to explain you why. My topic today is solutions for functional and innovative powders for granules, pellets, and with especially customized properties. India is already a very strong export company and will be even stronger in future. So it's more and more important to fulfill also international requirements and the requirements from your customers or the customers of your customer. So that's why we are always interested in to develop our technology further in order to be more flexible for you and also for the market, because this is at the end the most important thing, right? Just a few words to Glatt. Glatt is a German-based company. The headquarters is in the southwest of Germany on the border to Switzerland. There are several companies within the Glatt group. My company is located in the Middle East German part, and you can see here the red dots are all locations where we have our own employees. And you see India is already a very strong part of our company, so plays a very key role here. International, we have about 3,000 employees worldwide. And when you see the rough structure of our group, you can notice that it's actually split in two parts. One is the pharmaceutical and biotechnology part, which is actually the start from our founder, where he introduced our technology to the market. And when you read pharma is always high standards, high specifications, high regulations. So this is the part we started. Then in the 80s, it was introduced to the market that we can use the technology also for what we call FFF market, the food, feed, and fine chemical markets. And this is also why I'm here today. For the pharma, we are certainly one of the top 3 suppliers worldwide for our equipment. For the fine chemical industry, we are still exploring the world. So if you see Asia, for example, we are not more eastern than India so far, but we have so much potential. And also we see here at the exhibition with the inquiries we got yesterday, we've got already a couple of projects for the chemical industry here in India, which we have finished. But mainly we are in India well known for the pharmaceutical industry and the equipment for that. Just roughly the range of products and services. Actually, we can go the whole way together with the customer. From product development, particle design, we do the first feasibility tests with customer. We design the whole plant because we are actually engineering company. The core is a certain technology which is called fluidized bed. And this is what I would like to introduce you today. Here you see for the field, the industry which I represent, some examples what we are going to process with our technology, with our equipment, and some end products. Yeah? For example, fertilizers is very, very popular in India due to the farmer market, to the high percentage of farmer industry and farmers. Enzymes, detergents, flavors, technical salts, in fact, the whole range. When we talk about fluid bed technology, and this is our core, the core of our equipment, in fact, then we need to distinguish about batch and continuous. If we talk about batch, this is mainly for the pharmaceutical industry because here the throughput could be limited. And also because of the traceability in the pharmaceutical industry, batch-wise production is more common. What we are focusing on is more continuous operation with high throughputs and continuous running process. That means the starting material goes in and the final product comes out. And this goes step by step. How does it look like as an example? The pure example for such kind of, let's call it, process flow chart. So you have the equipment, the key equipment, and you put hot air inside the process chamber, which can be controlled very precisely by us. And we enter the material inside, and due to the hot air, the material will be fluidized inside the process chamber. And then we have the filter, and the exhaust goes out. But this is not the only effect we can have here. So the starting material and the liquid, but also the solid material. And here the liquid will be introduced to the process chamber with atomizing air under pressure into the fluidized bed process chamber. What we also got is, in fact, a circle, because in a continuous running mode with our equipment, and I will show you some examples, you won't actually having loss on material, because it's a closed cycle. So when the product comes out here, it goes through a sieve, and the two big particles will be milled and going back to the process chamber. Only the material which fulfills your specification will be go to the big bag or to the packing station. This is just roughly, because for our field, actually the systems are all customized, because everybody has different specification, different materials, different requirements. But just to give you an overview, I will show you later a very nice animation where you can understand it even better. Just to show you some of our equipment. So it can be round, like that one. It can be rectangular, like that one. This is a really big fellow, actually. This is located in Denmark. And this is a coater for coating particles. And this one has actually 72 nozzles inside, which are controlled by our control system. And the good thing here, the requirement from the customer was, for example, I would like to have a flexible production system. So if the market goes down, I don't want to produce the whole 100% output, which this equipment can produce, actually. So in fact, he can also run it with half capacity, third capacity. So he is flexible here and can react to the market. Yeah. This is also what we can offer in the discussion when we come to this project, to your project, about the requirements. But let's focus first on what also the topic of my speech says, of my presentation. How can we process your material? This is actually how we do it is secondly, but what we can do, this is the firstly and the most important thing. So we can offer the following processes. Spray granulation means from liquid to solid. Agglomeration means from fine powder, which might be dusty, too dusty maybe for your customer. We can create granules by adding a binder, and then the powder becomes a granule. Coating. Coating is super important for sensitive material, for material which need to be protected. I come back later with examples. Encapsulation, micro-encapsulation of liquids. That means, for example, if you have also sensitive material which need to be processed in a certain way, yeah? There's another solution. You can, for example, have a liquid which is not soluble in water, can be distributed in water, for example, or another liquid, and then we spray it in our equipment, and it also becomes a solid granule, which is, of course, solid. Powder layering is also encapsulation of particles or powders. I would like to shortly show you some examples and also how it works like. So spray granulation, we talk about liquid to solid. Some examples we've seen: vitamin, beta-carotene, ceramics. So there's a huge variety of products which we can process. Most important thing, liquid to solid. And how it works like is, so we spray the solution or the suspension in the process chamber, and by hot air, the particle moves and grows step by step until your requested particle size or range of particle size. So step by step, spray, the droplets is sprayed in the chamber, the particle moves and will be applied and grows step by step bigger until it reaches the size. Here you see a microscope picture of how such granule can look like. Of course, it's a bit depending on the material, but this is not unusual to have such a nicely round granule, yeah, which has some advantages. For example, you know, it's sometimes very difficult to transport liquids. And this is a very good alternative, bringing liquids into granules. You have less weight, less volume. It's easier to ship, as I said, and decrease also the handling hazards, just to name some of them. Spray agglomeration of powder is, in fact, you have a small powder, which might be too fine, maybe for your customer, or your first production step does not allow to have bigger particle sizes. And by adding some binder to bind together this small powder, you can create a granule. Some examples here, okay, this is mostly from the food industry, but just to give this as an example for the food industry, for beverages, for example, yeah, for powders, for beverages, when you want to add sugar or anything to your drink, then what is the main point? It should be dispersed very quick and very homogeneously. And this can be reached by having this process step. So that means you apply, can you see it properly? Okay, the video it's not shown perfectly, but maybe you can imagine. So the liquid is applied into the process chamber and combines the small powders. I show you a very nice microscope picture, and important for the very good solubility in the drink or in the liquid for this powder is that you get a big surface. And you see, here you see this granule has got actually a big surface, and which is important for the solubility later on. Yeah, the advantages are also, of course, dust-free, which is one of the main points here. Dosing properties are really good, and bulk density, porous structure, as I said, that is important for that kind of applications. Spray coating, encapsulation of particles with liquids. So here see sensitive material might be or need some protection. You see here some examples. Maybe we do it on this way. Fertilizers, for example, catalysts, again fertilizers, especially fertilizers. If the farmer puts the fertilizer on the field without a protection and it rains or will be watered, then probably it's not so efficient and the whole nutrition of the fertilizer goes into the soil very quickly and maybe it's not distributed homogeneously. But if you have a coating around the fertilizer, that can lead to a slow release. That means it's more efficient. So the fertilizer will be released to the soil step by step, not all in one. So this is actually more economical and can also save money. Yeah? So that's one of the examples why this coating is very popular. Yeah, just to see also a small animation. So again, the core of our technology is to apply in the process chamber hot air stream that leads that the particles move, and by spraying the coating material, it will be distributed homogeneously onto the particle. Yeah. Just another microscope picture. It shows actually very nicely how this coating can look like on a particle. So, coating, core material. Advantages are obvious, yeah. What I mentioned already, slow release. You can have certain functions. You can protect the core material from oxidation and so on. So it has quite a lot of advantages. Microencapsulation of liquids. So sometimes you would like to have a liquid into a liquid or in a suspension in order to embed it or in order to keep it in with the properties. For example, oil in the suspension. You want to release this oil later on with the final product. Then you can put, for example, oil in a water solution. So the oil won't be, because it's insoluble, it will be kept as oil drops into the water, will be distributed homogeneously. And then this suspension will be applied by spraying into our system. And the result is also a granule with the small, I will call it chambers, where your oil is still inside. It does not need to be oil, just an example. And again, how it can look like. Actually, it's the same like spray granulation, as I showed you at the beginning. But here, you have the sensitive material still inside without getting harmed, without getting damaged. And also here, the granules grow to the requested particle size. Just also an example, so protection for oxidation. Dust-free, of course, because all is dust-free, what we are producing. And the optical appearance, also important. And here you see it very clearly in this microscope picture. The small chambers are still here. That means the material which is into the solution or in the suspension keeps remain and will be also shown and have the properties in the solid state then and as a granule. Yeah, powder layering is in fact similar. So you have a powder, you have a binder, and this is for just different applications. Yeah, closed surface, high bulk density is also very often requested by the customer, and free-flowing properties, which is also important. Just to see the application particle structure in an overview, dust-free is always requested because who wants to open a bag and it's dusty, right? So the end customer, they want to have a smoothly use of the product, of the medium product or of the final product. To keep also for the coated particles, I just mentioned another example is to keep the taste. By coating, you keep the taste. Or if the material has a certain odor, a certain smell, then you can also close this by using a coating. Yeah. I would like to show you a short animation where what I just explained to you is shown to you more from the equipment side, how this works in the equipment. Here you see, this is a pilot plant, so a small production plant. So you see here comes the hot air inside. Here is the process chamber. We spray the material here. We can have top spray or bottom spray. As I said, it's only an example. And let's take a first the spray granulation as an example. So the hot air is introduced into the system. Here we have a bottom sieve, which is also a key material because this has some certain structure in order to make the particles move in the right way. We introduce the liquid into the chamber. And now you see there's the recycling movement I mentioned before. It goes, the product goes through a screen, and the two big product will be milled, going back, and will be reprocessed. Also the two small product going back. Only the product which keeps, or which is in the range of your specification will be go to the packing station. So, and yeah, this is the principle how it works. You see here different sub-chambers, I would say chambers, where we also can have different function. You see we spray only in 3 chambers. The 4th chamber is actually for relaxing your material, for have some relaxing time. Some materials request that. Yeah. This is for agglomeration, charging. Of course, here we give already powder inside, and we spray the binder, and here the material comes out. Yeah, I show you here the 4 key processes in one machine, but of course you cannot process 4 processes in one machine at the same time, so it's just animation to show you the principle of the different processes with our equipment. Yeah. This is for coating, in fact, is the same principle. Yeah, we always use air, hot air, which is controlled. We have heaters in our inlet air stream to control the temperature, what the material needs. Yeah, and also here, 3 chambers where we actively process the material, and the 4th one is for giving the material some time, because sometimes if the material is too hot and you go directly to a mill, for example, as a sub process step or post-coating step, then it can also lead to some problems in the mill. It can stuck, or it can be sticky. Yeah. Yeah, here you see filters. Filters can be, we can use different filters, but the filter section is also very important. Here you see an internal filter, but if your building is limited because an internal filter makes the system being bigger, we can also have an external filter which makes the system a bit more compact and can filter somewhere beside the system in the next room or so on. And we have also washing options. Here you see a plate filter, for example. I think these are the main parts which I would like to show you. And now, this is actually quite the standard, but Glatt is also always interested to listen to the customer and to process something further. Here you see spouted bed. Spouted bed. This was further developed by Glatt. Spouted bed is, in fact, you see, from outside looks the same, but there's a big difference. You see here, there is no sieve bottom. The air will introduce, and there are some, I would say, some plates where you can control the airstream. And this is really important for some materials, because some materials are heat sensitive, or you have heavy materials, so you need to adjust the airstream accordingly. Yeah? And this can be done with this. Our process engineers or our process engineer designer, when we come to the step to design your equipment, they will suggest you what way we go. If we go with the spouted bed or fluidized bed, which is better for your equipment, for your material, sorry. And this will be also shown in tests, which we always do before we design the final equipment. Yeah. So also the cycle is similar to the one I showed you before. Just want to keep your attention on the two different ways how to fluidize material. Yeah. Yeah, what I said, testing. Testing is very important, and going to the lab with you, or rather with your material, is the first step to do a feasibility study. With this feasibility study, we actually get the first idea how the material reacts. Maybe small things which we find out during the first feasibility test can make later a big difference when we design the equipment for you. That's why after the lab trials, the feasibility trials, and you see here our very flexible system. You see we can process here all our processes with one compact lab system. So what we always do is feasibility tests in a lab, going to the pilot plant to finalize the parameters, which is important, very important. And here you can also already get some material, some 100 kilograms from us for, let's say, preliminary tests for you or your customer. And then we go designing the production plant. This is the step how it goes. Lab, pilot, production. And here just an overview about the types of equipment we have here. The round one, what you saw before, we call it HET. This one is called GF, Glatt fluidized. And ProCell is the one with the changeable plates. And we have lab, pilot, production. What is important for a company which is very technology driven is to put also efforts in new developments. And I just want to show you on a couple of slides. Maybe it does not have in detail something to do with your products also, but I want to show you that we are an innovative company and we put a high amount of money into R&D. This is powder synthesis introduced just a couple of years to the market. And we have one reference in Germany. Fraunhofer Institute is one of the biggest institutes in Germany. And they have purchased our first system, which you can call a pilot system. It's located in eastern part of Germany. And what is here the difference? This is for very sophisticated particles, very small one, very special, high performance particles. We're talking here about sizes of, let's say, 5 to 50 micron. Yeah? Before, when we talked about granules, we talk about, let's say, 500 microns to 5 millimeter granules. But here, this is a different area of processing particles. That means you have a process gas flow. We have a pulsator unit which pulses the gas into, let's call it pipe, into the pipe and moving the particles through a very hot environment. The primary heater runs with a temperature of up to 900 degrees. You can even increase it for some applications, some material is necessary to, due to the calcination process, you need to have a higher temperature. You can go up to 1300 degrees. Yeah? And this gas flow produces a certain thermodynamic condition in the pipe. And you see here the two main processes we can do here. Micropowder out of a solution, similar to spray granulation, what I showed you before. So out of a solution, we create solid particles. Or coating of micropowder, solid particles will be coated, so on. You might ask, okay, what are examples? Examples for a final application is battery material, which is very common now all over the world, but especially in Germany, because everybody wants to buy an e-car. Everybody needs a battery. So material development is one of the key things in the next coming years. And here you can create very special battery material. Second one is catalyst. Catalyst material is also common. We have also some applications or some trials here. Ceramics and also pigments. So pigments, small particles. Another one is we call phosphor green. Why green? Because this is a very environmental friendly, environmental efficient method to get out of sewage sludge a fertilizer. You know, when water treatment, yeah? So every community has a water treatment facility where the wastewater is be cleaned. So if you see such a facility and the wastewater is be cleaned, what is left? A sludge is left, right? What to do with it? You need to recycle it, or there was no really use for it. And you can burn this sludge to become an ash. Then you can treat it in a certain way, and at the end you get an NPK fertilizer. This is amazing. This is amazing. It's new. We are the first one who did that. And the first production plant is since beginning of this year in 100% capacity use, output use. So here we are a forerunner for this. And I'm sure sooner or later this will become more important to India as well. Because recycling, environmentally friendly production, products, and also processes, this is the key for the future, I can tell you. So what we do is we have the ash of such water treatment facility. The sludge will be burned into ash. The ash is the starting product. Then it will be made a suspension out of this, so we make it liquid. And then the granulation takes place, as I showed you from our fluidized bed. So we spray this suspension into a chamber using hot air and then creating solid particles, granules, and this can be used as a fertilizer. We have done a lot of field tests in advance. Of course, you need to do it to convince the first customer and the institutes. And this is at least 100% comparable with another NPK fertilizer you can buy on the market. This is for sure. Okay, sometimes you have also some heavy metals into the ash still remaining after burning. There are also some steps how this can be separated. So no harm after that when you put the fertilizers on the field. Glatt in India, as I mentioned at the beginning, so we are very, very well represented in India. So in Delhi, we have an office for our chemical part, means food, feed, and fine chemical part. And in Mumbai, what you see here with Glatt Systems, which belongs to Mumbai and Pune location, here we are mainly in the area of the pharma industry. But here in Pune, we have a manufacturing site, a quite big one, which produces masses of equipment for pharma in India and the surrounding countries. And they also support us when we need equipment here for our continuous running processes. This is the office in Delhi, and this is the manufacturing site in Pune. So more than 500 people working there, so there's a high throughput on equipment. Because in pharma, as I mentioned before, is more, how can I say, they are more general equipment. That means the equipment is not so much diversifying from the continuous running equipment which we use for our chemical and food industry. Yeah, this is myself, this is my colleague, Mrs. Rana, and you can meet us at our booth at G12, and you're very welcome to join and have a conversation face to face. Thank you so much.
Yeah, actually, wanted to ask you why this, even though a lot of superior advantages are in APD, when compared to the scale and size of commercial, it is still not equivalent to the spray drying technology, where the volumes very heavy, and for the mass scale, for the cost of operation cost, the production cost is, I don't know whether I'm completely right or not. Why, particularly in agrochemicals, why this is not being looked into in large scale when compared to the spray drying?
You mean the operation costs?
Correct.
Okay,
correct.
operation costs.
Yeah.
Yeah, this is a good point. There's no general answer because the material and the process is varying according to the material. But we can say like this, that we introduced already a lot of energy recycle functions to reduce your energy costs. Energy costs at the moment are a big topic worldwide due to the crisis we obviously have. So we have, for example, a heat recovery system, heat recovery loop. That means the heat which comes out of the exhaust will be partly used back and using to heat the inlet air. This reduces the operational costs dramatically. Not dramatically, I would say drastically. Some customers say that. Then we can also use alternative heating methods.
Okay.
So, for example, electrical heaters, which are where the electrical comes from the solar energy, for example, something like this. So we also consider the running costs and, of course, the return on the investment then for your product. But I can tell you, due to the fact that this is a sophisticated, not only the fluidized bed equipment itself, also the up and downstream process, the whole plant, I would say. The investment costs are not super low, so you need a high throughput. Yeah. But this is our job to meet your throughput, which you tell us to do. So if you talk about 1 ton per hour, for example, is no issue at all. Yeah. So we talk about, and then this becomes super economical, flexible, and also quality for your customer and customer of the customer.
Correct.
Yeah.
Thank you.
You are saying about this NPK fertilizers from the ashes. Can it be developed on means like if you go for fertilizer industries, they treat like 200 kgs or 100 kgs per hour on a metal handling side. How could you match up with the same size when you go for this technology? Can we go up to 200 kgs per hour for individual nitrogen content or individual phosphorus content or individual potassium content? Will that be possible from this technological aspect view?
I'm not sure if I understood the last part correctly.
Okay.
So it's about the phosphor green technology.
Yes. Yes.
Preparation of the suspension until the final product. The recycling part cannot be used for another product so far, as I understood you correctly, or to get other products recycled out of these ashes. So this is not possible. I think the first question was about encapsulation. So perfume encapsulation, yeah, this is possible, and this we have done already in our labs several times for customers. Yeah, this I can also show you some examples when you come to the booth.
Engineering center that you mentioned you have in New Delhi, is that where you work with the customers to customize applications for them?
Yes. This is very important because every material, even it's the same group of material, reacts differently. And also the requirements of the customers are different because everybody wants to have something special, right? Everyone wants to differ from his competitor. So everybody wants to have their own formulation, for example, for liquids. And so this is the only point. I cannot do general statements about costs, about process time, about output. This is everything. We need to go together this way. This project is a high investment, so this needs to be sensitively prepared. Yeah.